In this video, we will describe the first steps for the creation of a simulation model that can be used for a virtual commissioning purpose. We are using here, for example, a body production cell for the automotive industry. We will focus on modeling the clamp table, and for this we hide the different robots for a more comfortable access to the clamp table model. We then select the clamps we want to model and activate the modification with the Set Modeling Scope function. The next step is to define the kinematic using the kinematic editor. We first select in the 3D view the reference elements used for the kinematic and give it the name base. The base will not move in our model. We create then two other elements. We call them links, that are corresponding to the moving parts of the clamps. The process is the same. We select the 3D elements in the 3D view and give it a name. We will call them clamp front and clamp back. By clicking on each link, we can identify them directly in the 3D model. Now we need to describe how these elements are moving in relation to each other. We keep the mouse clicked on the base link and drag it to the clamp back link. A new window appears to describe the joint. Two kinds of joints exist: the revolute joint for rotations and the prismatic joint for translations. We select here the revolute joint. Then we can select the starting and ending point of the axis of the joint by directly clicking the From and To point in the 3D view. Validate with OK. The same thing is done then again with the clamp front. It is possible to test the definition of the joints using the joint jog functionality. By clicking on the function, a new window appears showing the two new joints. By dragging the wheel of each joint, we can check that the rotations have been defined correctly for the two clamps. Don't forget to reset the position of the clamps before closing. The next step is to define the different positions we can have for the clamps: the open position and the closed position. Click on the Pose editor next to the Joint Jog button. Click on New to create a new pose, give it a name as well as the position of the different joints. The open position, for example, gets the angle 90 degrees for the second joint and 0 degree for the first one. You can check the result in the 3D view. We create then also a closed position, where the first joint gets a 15 degrees angle and the second one gets back to 0 degree. By selecting one of the positions, open or closed, in the pose editor and then clicking on the Move button, I can check that my poses and kinematic are correctly defined. The 3D model with its kinematic can now be saved. Ending modeling locks the component. It's not possible to edit the kinematic. We can nevertheless still check that the poses are working correctly. Last step to get a full smart component is to create the signals that will drive the kinematic of the clamps. Start again the modeling scope and go to the Control tab. Now select the wizard to create a smart component and check the poses we will want to use. Here we select Open and Closed. A logic resource is created. We can now open the logic resource and look at its structure. It has two entry signals, which are the command to reach the poses, and two exit signals representing the sensors for the poses. Actions trigger the kinematic of the model. Here is the entry signal definition. Here we can connect the PLC signals we will define later. Here is the exit signal definition for the sensors. Parameters describing the behavior of the sensors are defined here. Sensors are in this case linked to the position of the kinematic. We can select which pose will activate which sensor. And finally, in the Actions tab, we can define the conditions to make the 3D model move. Here, the clamp will open when the RMTP open entry is true and closed when the RMTP closed entry is true. We create now a new TIA portal project where we will define the signals and the logic of the PLC. Select a PLC that is going to be used in the project. 1500 CPUs can be used with PLC Sim Advanced. Create 4 new signals corresponding to the open and close actions for the clamp, as well as 2 inputs for the position sensors. We can copy-paste the 2 signals in the watch table to trigger them later with the simulation and observe the sensors. And we save the project. Because the project will be compiled and loaded on PLC Sim Advanced, we need to activate the support of simulation during the block compilation in the project properties. In PLC Sim Advanced, we create a new instance of a CPU to be used for the virtual commissioning tests. The CPU is at the beginning empty and not running. Finally, compile and load the project on the new created instance. And start the instance. PLC Sim Advanced shows now that the instance is in run mode. The last step in TIA Portal consists in exporting the signals in an SDF file to import them then in Process Simulate. In Process Simulate in the Control tab, select the Import Signals option. A new window appears where the file generated in TIA Portal can be selected. Drag and drop the signal names in the signal name column and do the same for the type and the address. Remove the header row. We want to have all 4 signals available in Process Simulate. We can hit the Import button to create the new signals in Process Simulate. The 4 new imported signals are now visible in the Signal Viewer window. The next action consists in connecting those signals with the logic resource previously created. Select the clamp in the 3D view and in the Control tab, select the Edit Logic Resource option. In the Entries tab, select the RMTP open entry and associate it to the open signal by selecting it in the Signal Viewer. Do the same for the close signal as well as for the sensors. The final step is to configure Process Simulate to connect to PLC Sim Advanced. Go in the File, Options menu and select the PLC option. The CEE option is selected by default. The CEE is an internal Process Simulate engine to trigger the simulation events. Here, we want the events in the simulation triggered by the PLC. Select the PLC option, External Connection and the connection settings. Add a new PLC Sim Advanced connection, give it a name and select the created PLC Sim Advanced instance. In the Signal Viewer, activate then the external connection by selecting the PLC in the drop-down list for the 4 signals to be connected. Save the project and move to the line simulation mode to activate the simulation connected to the PLC. Start the simulation. The time is running now. Go online with the PLC in TIA Portal. You can already notice that the AT closed signal is true, showing that the clamp is closed. This is the default position in the model. And test the model. A simple simulation connected to the automation is now complete. The steps can be repeated to other components of the line to lead step by step to the virtual commissioning.
Siemens. Ingenuity for life.